So before we start, you can go to the Mvapitch web page and download the slides from there. Those who want to get ahead of the slides, on page 40 onwards, we have hands-on sessions. And yes, all of you will be able to log into AWS and actually run Mvapitch applications on multiple nodes equipped with GPUs, all on AWS. And I would like to thank AWS as well for giving us the credits for this. And thank you very much for the Ohio State University for inviting me here today. I will describe the ParaTools Pro for E4S, a cloud image that supports HPC and AI workflows. So as our software gets more and more complex, it's getting harder to install our tools and libraries in a consistent manner. And it gets even more frustrating if you are trying to use these in a cloud environment. So there has to be a better way. And that's the main motivation for our work here. The key question I want you to think of is what makes for a productive HPC AI environment on these commercial cloud providers. So with that, I want to introduce the extreme scale scientific software stack, which is an ecosystem for science, for high performance computing, as well as AI. And we are exploring other fields such as electronic data automation, EDA tools, as well as in the future, even quantum computing. So what we have here is a curated SPAC-based distribution. SPAC is the package manager. It's an HPSF project, just like E4S. And we have built a number of packages using Mvapitch as our core on cloud platforms. And you can see some of the AI/ML tools that we include. This includes NVIDIA NeMo for generative AI. It includes NVIDIA BioNeMo for drug discovery applications, protein folding in particular. And it includes VLLM. It has Hugging Face command line tool. So you can easily connect to what we know as the GitHub of AI models to download the models. It has TensorFlow, PyTorch, OpenCV, and these tools are actually built for the GPU. So you don't have to worry about whether it's running on the CPU or the GPU. There are other tools like TorchBraid, Scikit-learn, Pandas, JAX, LBAN from Livermore, with support for GPUs where available. And we also have containers, big images, full-featured images, and there are tools to allow you to do more. And I'll talk a little bit more about that. Our latest release was at ISC. We have releases twice a year. The next one will be at Supercomputing. And here is the web page, e4s.io, where we can download containers using Docker or Singularity, Apptainer. And there are containers for CPUs or GPUs to reduce the size and GPU-specific versions. So you have a GPU architecture based on AMD, NVIDIA, and Intel GPUs. And you can have the base images or full-featured images. And you can see there are images with no GPU runtimes or with GPU runtimes. And there are tools like E4SCL, which is a container launch tool. You can build your application, an MPI application, using the MPI library in the container. And on your system, if you have Mvapitch installed, you can substitute the MPI in the containerized binary with the system MPI. So you can now ship HPC applications in a binary form. You don't have to give out source starballs. You can use a container. You can substitute the MPI at runtime. This is how it works. We have other tools like E4S a la carte, which allows you to take a base image and customize it. Say, start with this, add just these 4 packages, create another container image for me without having to write Singularity files, without having to write Docker files. We have our infrastructure built on SPAC. And with SPAC, we have this complete ecosystem of tools that allows us to use not just the HPC tools, but a large number of other packages that are available through SPAC. If you want to use SPAC, you can simply clone the SPAC repo, set up your environment, and say SPAC install a package name like tau, and it will install tau and all its dependencies within the SPAC directory. You can also find the compilers, find external tools. A lot of this is changing in SPAC with the release of version 1.0, where compilers are not treated like a separate compiler, but as a package. So you don't have to give %sign anymore. But this is an example of using a tau package, specifying versions, compilers, and even variants and build options, where you can say use it with MPI, with MVAPICH version 4.0. And it is a very mature package manager. It's part of HPSF. Learn more about it at spac.io. We have allowed our containers to chain to SPAC instances. So one can be in the read-only file system and another one in your home directory. So when you say SPAC install a package, it doesn't give you an error saying that you don't have write permissions to the read-only containerized file system. It installs it in your home directory, and you can see a union of packages that are pre-installed and those that you install and customize your software stack in this way. So it uses dependencies from what is already installed in the container, and then you can launch a tool like this. Now just have a look at some of the examples over here. In our latest release of E4S on the cloud platforms, we have the Google ADK, Agent Development Kit, pre-installed with all the libraries. And you have all of these Python packages, such as Google's Gemini, OpenAI, PyTorch, BioNemo, Nemo, Hugging Face, JAX, Pandas, CV2, Scikit-learn, even MPI for PY, and Matplotlib, Seaborn, Plotly, VLLM. These are tools that you typically need when you are developing AI applications, and all of these are available in the image, both in container and on the cloud. Here is a sample of some of the example of some of the tools that are present. And we have other tools, including Firefox, Codium, or Visual Studio equivalent tool, Jupyter, and even Marimo notebooks, reactive notebooks. You can see here is the output. Here is an example of a BioNemo workflow in a Jupyter notebook. We can also launch it in Codium. And then you can run all of these cells and get the results like this. You have VLLM, so you can run your own chatbot on your own GPU and run an example. Plus, you have a remote desktop, so you have visualization capabilities like this ParaView. So ParaTools Pro for E4S is the cloud image, which allows us to target multiple cloud platforms. Now, moving to the cloud is an important step, but you have to make some conscious decisions. Which MPI is the first question that you will encounter? There are multiple variants, but we found that MVAPICH is the most suitable in this case because it targets all the network adapters efficiently across the different cloud platforms, even if it is EFA on AWS or InfiniBand on Azure or ConnectX-5 or IPUs on Google Cloud. And we also use for intra-node communication XPMEM, where you need to have a driver and kernel module. We have support for MVAPICH Plus on all of these platforms. And we use HIDE, Adaptive Computing's HIDE interface, to launch these jobs on multiple cloud providers with a single common web-based interface where you can have a remote desktop environment. And so this is how it looks. You can submit jobs to on-prem systems as well as on the cloud systems where a user can deploy the workload on different cloud providers. And the E4S on commercial clouds is a project that was funded by the Office of Science, Department of Energy, through the Small Business Innovation research program with support from the Xscale Solutions LLC as well as the Ohio State University. And we used MVAPitch and integrated it with all of these different cloud providers. We support both Slurm as well as Torque-based schedulers and use different environments, including the Heidi as well as the native environments provided by the different cloud providers. Here is an example of using Heidi, which supports multiple users on each cluster node and multiple clusters. So for the hands-on, I have launched 4 clusters with compute nodes, with login nodes, and we'll have a shared environment where all of you will log in and try it out. So this is the image that you can subscribe to on the cloud providers web page. This is in the marketplace on all those 4 cloud providers that I mentioned. This is on AWS, and we support NVIDIA GPUs as well as Trainium and Inferentia ASIC nodes that are available on AWS using the NeuronX SDK. It's also available on Gov Cloud, East and West regions, and supports EFA efficiently with MVAPitch MPI. And as I mentioned there, this is the integration work done by Xscale Solutions LLC and the Ohio State University. This is the image on Azure with Slurm as well as Torque. And this is on the Google Cloud Marketplace. And this is on the Oracle Cloud Marketplace. This is how the system looks. You have Podium for Visual Studio, equivalent editor. There is the Tau Performance System that I'm also going to talk about tomorrow. And you can, of course, use your own AWS credentials or any cloud provider credentials. All you have to do is go to the marketplace, search for the image, sign up for it for the free trial for the first 31 days, and then go to Adaptive Computing, start your free trial, and then they'll help you integrate your AWS credentials with this. For the hands-on, I have set up this site, paratools.adaptivecomputing.com. You can launch a Firefox private window. The goal here is, how can I engage with hundreds of users, some online and some on-prem here, without giving out individual IP addresses and passwords and usernames? How can I have a secure environment where each user has their own set of files? And to do that, all you have to do is go to this web page and then use that student code of 70034. So this is the web page. Navigate to, don't go to the admin or instructor. Go to the 3rd tab there, which says student. Fill in your name, fill in your email address, and put in this special code that we have for this workshop, 70034, and you can begin your hands-on session. It will send you a 2-factor authentication email to your email address that you specified. And then you will be able to just log in and start a remote desktop. Now, I know you may have tried logging into AWS or some of the cloud providers yourself, and it was very painful, right? This makes it very easy. You just get the 2-factor authentication code. You get an interface that looks like this. It shows you the name of the cluster. You click on that cluster and click on Remote Desktop. Now, all of you may not be happy with using a remote desktop. Maybe you want to use a terminal window. And if you want to do that, you see over here, there is a SSH key. You can download the SSH key and then run this command in the middle of the screen here, which says chmod 600, change the permission of the SSH key, and then use that key to log in to that login name and that IP address. So you can do it without that, but then you won't get the full power of the remote desktop. So I highly recommend that you click that button and get a screen that looks like this. You may have to open up pop-up windows, and then you should see something like this. So if you get this jellyfish, then you are all set. You can copy text to and from using the clipboard over here. You can click on the Activities tab, open up these 9 dots, open up a terminal application, and then we can get started. So let me go right back to this and go to this web page. And even users online on Zoom, please go ahead and go to this web page, put in that code, and you should get an email. I prefer to use a Gmail address in such a case so it doesn't get filtered out by institutional filters and spam folders. And with this, you should be set up like that. So just a show of hands. Are you able to go here, do this? Are you able to get the remote desktop? Okay, great. So you got a terminal session. I'll wait for others to catch up. In the MVAPITch users group meeting, we have to run MVAPITch workflows, right? So this makes it easy for us to just scalably connect and balance the load across multiple clusters. You will see that if you say NVIDIA SMI, there is a GPU on the login node, which is accelerating the remote desktop. Now, I have chosen instances in the US West 2 region of AWS. So that's in Oregon. I come from the University of Oregon, so it's a natural choice for me, but just because I had the quota over there, I have chosen there. So we are running the full remote desktop across the country. And we are running, dozens of people on each login node. So you don't have one cluster allocated to each person, but you're sharing, and we are using Torque. So you will see, you have to say qsub to run the commands. So just a show of hands, are you able to log in? Are there problems in logging in for others? Please raise a hand if you're facing a problem. I would encourage everyone to try this. I know some people just prefer to see PowerPoint slides, but this will change your perception of using cloud-based systems. Yes? No, you can use any, I'm in fact using Safari on my laptop, but I know that for most people, Firefox private window works well. Sometimes you may have to tweak your VPN settings or something where you turn off the VPN, but in most cases, this should work. Are there users online who are having any issues? Are you able to log in? Yeah? Okay. So here, you will open up a remote desktop. Is remote desktop working for people? Are you able to see this? And open up a terminal, click on activities like this, open up a terminal. Maybe even right-click on this, go to preferences. If the font size is not good, just go to custom font, click on it, and change the size of the font. Here are some examples. I'll start out with the simplest one, where we have a MPI processor name example. We'll just run it on a single node, then cat this qsub file and run it on a compute node, and then see the output and look at OSU benchmarks. Now, on these instances on AWS, I have chosen EFA, Elastic Fabric Adapter, which has a rated speed of just 50 Gbps, 50 gigabits per second, between 2 nodes allocated in the cluster. Now, part of the reason is it just costs like 53 cents an hour, and it includes a GPU. So it's a cheap instance which has a GPU and an EFA, and it has 50 Gbps, not bad. But see how close to 50 you can get with MVAPitch, okay, using the OSU benchmark. I would love to hear from you what numbers you are seeing. I'll show you how I'm doing this. I go to examples, MPI proc name. And here is the MPI proc name.c. This is the first thing you should do when you go to any other MPI installation. Make sure that the batch scheduling system is in sync with the MPI library. So if I say compile.sh and it compiles it, and if I say MPI run-np4 MPI proc name, this is running on the login node, not recommended, but still, you can see ranks going from 0 to 3 on that compute, on that name. And I can say MPI proc name dot qsub. So here I've said, please allocate 2 nodes with 2 processes per node, so 4 ranks total, and give access exclusively to me. So I can say qsub MPI proc name dot qsub. And then I say qstat dot -u $user, and then I see that my job is queued for execution. Okay, very simple. First step that you should try. What I want to see is that these are 2 separate nodes on which MPI jobs get scheduled, that they have distinct names for the execution. And then you will see, after it runs, you will see something like output files like these. So if you see the output, you will see that there is 2 ranks on 0, 1 and 2 ranks on 0, 0. Okay? So with this, if I go to the OSU benchmarks and look at the same bw.qsub, I see that it is using 2 nodes with 1 process per node. So now I have put 1 rank on each of the 2 nodes, and I want to measure the bandwidth that I can see with MVAPitch between the 2 EFA-enabled nodes. Okay, so I say qsub bandwidth.qsub. And so you see that MPI proc name completed. This is queued. And if it says R, then it's running. This is the status of the job. And there are 2 tasks over here. So now this is completed as well. And I see there is a bandwidth.o, this file. Let me cat this. And the figure I'm trying to reach is 50 Gbps. Now this is megabytes per second, okay? So let me just use BC and multiply this with 8 to get megabits per second. And it's right there at 50 Gbps. Okay, taking the factor of 1024, we are getting 50 out of 50 Gbps. I would love to hear if you are able to run this job and what figure you see on the benchmark. Here, this is the number I chose, but even these are very close to 50 Gbps as the bandwidth that we get from MPI. So we have an environment where I have a number of packages. Here is pack output, 166 packages. You will see packages here like OpenFOAM or GrowMax or NEC 5000 or even CP2K. These are all built with support for GPU where available. So I can say plus CUDA, and I can see, for example, this version of LAMPS is built with support for CUDA. And you can see all of these packages, including Tau, which support CUDA, and you have access to a GPU. What is interesting is if you say GLX info on this, it doesn't say Mesa OpenGL. It will show you that it's using NVIDIA Corporation. So it's GPU accelerated. So even if I launch things like GLX gears, as we normally do, and get like 30, 40 frames per second, we can see that in this case, I'm getting 2874 because it's just a simple T4 GPU, but it is running the full desktop on the GPU. So even if I run this remotely with applications like ParaView, which is a 3D graphics application, and I pick, say, example visualizations like this, let me pick this one and go full screen. You can see that I can rotate this in real time, like I would on a local desktop workstation, because it's running on that GPU. And even if it's across the country, from Oregon to Ohio, and the whole classroom is doing this with a shared login node, we'll still be able to get reasonable graphics performance with 3D graphics like that. So we have an environment where you have a remote desktop which is very responsive. You have a number of HPC packages, and we have a large collection of AI packages, including Google ADK, and set up so that I can install other commercial third-party tools and customize each student's software stack. So that is the key, that you can install any package that's not installed here. It will automatically install in your home directory and show you the union of packages that are centrally installed and that are installed for your user. You can bring up multiple clusters, do load balancing across clusters for the students. You can easily stop a cluster and restart it to bring the same files back the next day. And you can have a whole collection of these tools, including Codium or Jupyter Notebooks or Marimo, and launch them and customize it. We also have access to a very high performance centrally installed file system from volumes that you can mount so that you can have, for example, if you had an AI class and you had, say, 50,000 images that you wanted to write to a shared directory that all the students would read from, then you would just connect that volumes partition. It will be mounted on the compute nodes as well as the login node, and everyone can then read from it at a very good speed. So with this, I'll pause here because it's more important for you to try these examples. So CD to the examples, OSU benchmarks, and just qsub bw.qsub. And try this. Okay, this will be a good first case of starting your MPI. If you have your own applications, I'll say please go ahead and do a Git clone and build it in this image running on AWS. Are you able to all connect to it, launch the terminal, try some of the AI packages that are installed here as well? You will be surprised with the collection. I say which ADK, and I have the Google ADK installed over here. I can launch commands over here. If I wanted to install my own tools, even commercial tools, I can do that in this image. And what is interesting is that the same image is available on multiple cloud providers, including in their marketplaces, AWS, Azure, Oracle, and Google Cloud Marketplace. There are some other examples here that I have provided in the slides. You can feel free to skip ahead and try them. Here is Visit, another visualizer from Lawrence Livermore National Labs. I'm going to examples Visit. I click on that, and I can then just open up an example.silo and click on this add. And let me choose pseudo color pressure. And then click this draw button over here. You see this draw button? And then there is a cube here. And you can see I can slice and dice this by going to operators, going to slicing, isosurface, and click this draw button. And you can see. So this is a performant desktop. And I can launch other tools from within this. Here is PyTorch. If I say Codium, I can launch the Visual Studio. Click on this, extensions. Even search for new extensions that I want to install, like Python. And if I click this, fourth one, Python, and install, it will install the Visual Studio extension of Python in my own directory. And then I should be able to just launch a Python application by clicking open a folder and then going to say examples. Let me pick PyTorch and then open this folder. It asks me if I trust this. I say yes. And then I see the files over here. I can click on F2 and you see the syntax highlighting is there. I can simply click this play button here at the top, and it will run this inside the terminal, and I'll have PyTorch application running here. Do you see it says Tesla T4 GPU? So I have some examples that are there in the slides. Please try them yourself. I would love to hear if you are able to use this, and if there are some packages that we do not include currently that would make this more productive, and if you are able to install them. There are, of course, some commercial tools that we cannot include in our workflow, but we have made it an image that makes it easier for you to install your own packages. So here are some other tools. For example, if I see there's a, are you aware of Anthropic and Claude as a company? And they have a subscription-based model, so you need to install it. But to install Claude, you need to have Node.js, you need to have NPM, need to have NPX, and all of those tools are pre-installed in our environment. So all you need to do is say npm install this Claude Code, and then it will be in your environment. So let's just try this. I say, and which npm? So you see it's installed already. npm install -g for global at Anthropic AI/Claude code. Okay, and then it will install it over here. So if I say which Claude, I can launch Claude like this. Now I don't have any subscription here, but you can see that it's working. So it's very easy to install third-party tools and just install other tools in this environment and customize this environment with support for GPUs. So that is the key, that you can launch workflows. There's a PETC example here. And I can again say compile.sh, and you'll see many PETC libraries and other third-party libraries like Hyper, OpenBlast, Parmetes, all linked into this application. And you can say LDD EX50, and you'll see all these application libraries built with MVAPICH Plus, built with MVAPICH 4.0 Plus. And then you can easily run this by saying qsub ex50.qsub, for example, or run it with tau, with tau.qsub. Here I have added tau exec -EBS before the name of the application binary. And that can be used to profile your application. More on that tomorrow, but so just for feedback, were you able to go and log into the AWS cluster? Were you able to go and do this? From slide 40 onwards? Yeah, and okay, and did you get the remote desktop working properly? Were you able to launch a terminal, launch MPI applications? Are there AI packages that you can see and run? There are some examples, directories that you can directly use. For example, if I wanted to use JAX, I could just go to JAX over here, cat run.sh, and say run.sh like this, and it will then use the JAX package with this Python tool. Okay. So please try this image out. That's really what this is all about. Just running our AI ML workflows, our HPC workflows in an environment which allows us to have a performant remote desktop all running on AWS, where we can launch our jobs in a supercomputer-like environment, where we are doing a batch submission using the nodes allocated, using a batch scheduler like Torque, and running our AI workflows, whether they are TensorFlow, PyTorch, like this. And running Codium and Jupyter Notebooks, even Marimo. So here is an example of Marimo. Let me just show you how to cut and paste between environments. This is on my local laptop, and I can say copy over here. If I say Marimo new, then I can get this. I'll open this button, open the clipboard over here, and here I can put down this and then cut and paste it in this location. Now I have got this, and I can then say Shift Enter. I can run this cell, and you see this graphic pop up. One of the advantages of Marimo compared to Jupyter Notebooks is that the collection of cells auto update. When one of the cells is updated or some global value is changed, all the dependent cells automatically update with that. So that's just an example of graphics working with within web browsers for Jupyter Notebooks, Marimo. So I'll pause here and take any questions you may have. About this project. Any questions? So these are the list of some of the packages included in ParaTools Pro. I would like to thank the US Department of Energy, the National Nuclear Security Administration, the Department of Energy's SBIR program, STEP and PESO projects, and the exascale computing project. And our collaborators at The Ohio State University Xscale Solutions, LLC, for their support of the project. So I'll keep the images running for a little bit. If you want to continue using them, please contact me. I'll bring up these clusters on demand if you would like to try them out, and let me know how I can help. You. This is the Heidi interface where I have multiple cloud providers, multiple images, and I can hold several workshops. This is one of the workshops with this code, and I have these 4 clusters running over there, and I can see the load balancing between the clusters. Okay, and you can also check what each student is doing. If you want to monitor that, you can see active VNC sessions and things like that too. So it's a very interesting environment where you can create multiple sessions and launch images, the E4S images that are available from multiple cloud platforms. So any questions before we wrap up? Yes, please.
Thank you for the nice tutorial, Dr. Shende. So one of my questions is about the platform of this. Is this existing platform like open source, like this management view?
So are you saying, is this package from adaptive computing, the Heidi interface, is this an open source tool? And the answer is no. It is a commercial product which is used to launch the image. The image is available on the marketplace as well. And you have to, you can get a 30-day free trial for both of these packages.
So name of this platform is Heidi.
Heidi is the name of this platform from adaptive computing. And this is used to just connect to the images that are available on the marketplace.
It looks very fancy. Another my question is like, so isn't like it's supporting multiple different cloud vendors like Azure. Oracle, maybe Oracle?
Yeah, we have Oracle, Azure, Cloud, all 4 vendors. You can go to ParaToolsPro.com. And you'll find the listing of all of the cloud providers and the images and where they are over here. You can see ParaTools Pro for E4S. And you can see Amazon, Google, Microsoft Azure, Oracle. You can just click to their respective cloud platforms like this is on Google Cloud.
So one of my question is, can you connect, can you make a cluster with different types of clouds? Like, have you ever thought about that kind of concepts?
So what I can do is in the same workshop that I have over here, I can easily pick another cloud provider. I just say add cluster, and here there's a cluster that I have configured on Azure. I have configured a cluster over here on, say, Google. So I can add clusters over here in round robin. It will transparently move new users to these additional Azure and Google clusters, which will have the same identical setup, but different backend compute nodes with different. On Azure, you'll have InfiniBand, for instance, as the interconnect. But MVAPitch will provide a uniform interface, and you'll be able to use all of those applications the same way across the different cloud providers.
This looks amazing. Thank you.
Thank you. Any other questions before we wrap up? Anyone online have any questions? Were you able to try? Amit had a question.
What was the interconnect in this testing? The latency was 14 microseconds.
That is correct. And Elastic Fabric Adapter on AWS in this particular instance is configured with 14 microsecond, but 50 Gbps network. I could have chosen a more expensive node and it would have better performance. And I have just chosen this because it was cheap. It was like 53 cents a node hour for a GPU with EFA. So that makes for a very compelling, hands-on session.
Oh, it's fine. Just asking.
Yeah. You can pay more to get more performance. That's what the cloud providers are saying, right?
So if there aren't any other questions, let's thank Samir for the wonderful tutorial. So